You've probably seen the headlines, right? AI beating the world's best players at super complex games like Go. And you might wonder, how on earth does that happen? It's not magic. It's actually a journey. And today we're going to walk through the map that guides an AI from knowing absolutely nothing all the way to total mastery. So let's get right to it. It all boils down to this one fundamental question. We hear a lot about massive computing power and giant data sets, but the real secret sauce, the magic, is in the learning process itself. How does a machine, starting completely from scratch, even begin to understand the concept of winning? Well, the answer isn't some single complicated formula. It's actually a story. A quest, you could say, almost like a hero's journey. And just like any great story, it's packed with challenges, moments of discovery, and a whole lot of trial and error. So, our story kicks off with the AI agent's very first task, its most basic motivation. And this brings us to Section 1, the quest for reward. The guiding principle for this whole quest is something called reinforcement learning. So picture this, you have an agent, let's call it our hero, and it's dropped into a new world. It learns by just trying stuff. If an action leads to something good, it gets a point, a reward. If it's a bad move, maybe it loses a point. Its entire existence is about figuring out how to get the highest score possible. That's it. Okay, so let's break down the cast of characters here. First, you've got the agent, that's our learner. It's exploring its world, which we call the environment. At every single moment, it's in a specific situation or state, and it has to make a choice, an action. Then, the environment gives it a reward, positive or negative, which basically tells the agent, hey, that was a good choice, or nope, try again. This simple little feedback loop, that's the foundation for everything. Okay, so our hero knows its mission, get the reward. But how does it even begin to navigate this world to find it? Well, that requires a new tool, which brings us right to Section 2, mapping the world. I mean, seriously, you wouldn't send a hero off on a quest without a map, would you? Of course not. And it's exactly the same for our AI agent. To act intelligently and not just wander around bumping into things, it first needs some way to understand the rules of its world. Now, that map has a pretty technical name, a Markov Decision Process, or MDP. But please don't get hung up on the term. Just think of it as the ultimate rulebook for the game. It describes every possible situation the agent could find itself in, every single choice it could make, and what's likely to happen next. It's the blueprint of its entire universe. So, our hero has a goal and a map. Now what? Well, now it faces a really fundamental choice in how it's going to use them. And this leads us to Section 3, 2 paths to mastery. And here's where the strategy really comes into play. There are 2 main paths. On path 1, if our agent has that perfect map, that MDP, it can use it to plan everything out in advance. I mean, it can literally calculate the absolute best path to victory before it even makes a single move. But on path 2, if it doesn't have a map, it has to learn from scratch just by doing things and seeing what happens. So, as you can probably guess, this presents a major trade-off. Planning with that perfect map, yeah, it'll find the absolute best solution. But let's be real. In the real world, we almost never have a perfect map of anything. Learning without one is way more flexible, but man, it can be a slow and sometimes pretty painful process of trial and error. This whole trial and error thing works pretty well for simple games. But what happens when the world is just too big to explore every corner? That brings us to the next huge challenge in Section 4, learning to generalize. I want you to just think about a game like Go for a second. The rules themselves are pretty simple, but the number of possible positions on the board, the number of states our agent could be in is, well, it's just staggering. It's truly mind-boggling. So, how mind-boggling are we talking? The number of illegal board positions in the game of Go is greater than the estimated number of atoms in the entire known universe. Yeah, an agent could play for trillions and trillions of years and never, ever see all of them. This creates a gigantic problem. I mean, if our agent learns by experiencing things, how in the world can it learn to play well when it can't possibly experience every single situation? Memorizing the best move for every state, it's not an option. It's literally impossible. The answer is that it has to stop memorizing and start generalizing. It learns to approximate, to estimate the value of its actions. Basically, it develops a kind of AI intuition. So instead of needing to see an exact board state it's seen before, it learns to recognize patterns. It learns that boards that have features like these, maybe a strong position in the center or connected stones, are generally good. This is such a crucial leap because it lets the agent act intelligently in situations it has never, ever seen before. Alright, so armed with this new intuition, our hero is almost at the end of its journey. But of course, it has to face one final test. This is Section 5, the ultimate challenge. And this brings us to one of the most famous, most crucial dilemmas in all of AI, the exploration versus exploitation trade-off. It is a constant, delicate balancing act. Do you exploit your current knowledge and just do the thing you know works? Or do you explore a new, uncertain option on the off chance that it might be even better? Here's a super simple way to think about it. Exploitation is ordering your usual favorite pizza. You know it's going to be good, it's a safe bet, a known reward. Exploration, that's trying the new sushi place that just opened down the street. It might be terrible, or it could become your new favorite spot in the world. You're risking a pretty good thing for the chance it's something even greater. And that's it. That is the final piece of the puzzle. Real mastery, whether it's for an AI or for us humans, comes from knowing when to play it safe and when to take a risk. Mastering this delicate dance between exploiting what you know and exploring the unknown, that's how an AI truly learns to win. And just like that, our hero's journey is complete. We've watched an AI go from knowing nothing to seeking rewards, to mapping its world, developing intuition, and finally mastering risk. So if this is the map an AI can follow to master some of the most complex games humans have ever invented, it leaves us with one very powerful question. What will it master next?